partial differential equation is, we have to find the partial differential equation of the function z is equals to f of x square minus y square. Now let us differentiate this z with respect to x partially. So it is dou z by dou x. Differentiation of f of x is f dash of x, and the differentiation of x square minus y square is 2x. Let it be some equation 1. Now we'll differentiate z with respect to y partially. So it is f dash of x square minus y square into differentiation is minus 2y, which is equation 2. Now we have 2x here and f dash of function. We have 2y here and f dash of function. If I multiply y to the first function and x to the second function and add, then the result will be 0. So it is y into dou z by dou x plus x into dou z by dou y will be equals to 0, which is nothing but option B.
Question is, the block diagram for a control system is shown below. For unit step change in the set point, the steady state offset in the output y of s is. We know that the steady state error equation, that is limit t tends to infinite ess, this is nothing but s into r of s limit s tends to 0 1 plus g of s into h of s. Here h of s is 1, g of s is nothing but 2s, sorry, this is 4, numerator is 4, this is 2. So 4 by 2s plus 1, 3s plus 1 is the open loop transfer function. Here r of s is 1 by s. Hence, steady state error ESS equals to 1 by 1 plus limit s tends to 0 g of s, which is nothing but 1 by 1 plus 4, which is equals to 0.2. Hence option A is correct. Question is, ideal electron and hole current components through p-n junction under forward bias match least with the graphs. Here this is p-type material. In case of p-type material, these are D indicates electrons. Means what? Here these electrons, because these are the minority carriers, they are going to move higher concentration to lower concentration. Hence D is the electron diffusion current. That means S is nothing but a D. Here comes to A. In p-type, A is the means this is the whole current. Whole current is because majority current is mainly in case of drift current, that is whole drift current, that is P is A. If comes to B, whole diffusion current, that is Q, and comes to C, electron drift current, that is R. Okay, so P, Q, R, S, A, B, C, D. Hence option B is correct. The question is, if the system of figures shown below is linear, causal and time invariant, the frequency characteristics of the corresponding to the signal input are respectively. See, we need to identify one thing. See, before looking to the question, we should know that for an LTI system, continuous leads to and continuous and aperiodicity and discrete and periodicity. These two are the transform pairs. Means in the time domain, if it is continuous and the periodic, in the frequency domain it is going to be discrete and aperiodic, so vice versa. So now if we look into the figures, time domain signal is periodic and continuous. Means what? The frequency domain signal has to be a periodic and discrete. So this is the figure A, this is the figure B, this is figure C, this is figure D. Now if we look into the relation between A and B, this is continuous and periodic, so this is discrete and aperiodic. So A is B and C is D, because C is, this is discrete and and aperiodic. Means if it is discrete, it is going to be periodic, 0 to 2 pi, again 2 pi to 4 pi, 4 pi to 6 pi. So it is aperiodic, means it is going to be a continuous spectrum. So C to D, hence option D is correct. Question is, a series RLC circuit has 10 ohm resistance, 60 millihenry inductance, C farad capacitance. At a frequency of 25 Hz, the power factor of the circuit is 45 degrees lead. At what frequency will circuit be resonant? See, we know that tan pi is nothing but Xc minus XL by R. So tan 45 is 1, so R equals to Xc minus XL. Here Xc is 1 by omega C, XL is omega L. Here omega is 2 pi, F is nothing but given in the equation, that is 25, that is 50 pi. So if we solve like this, that is 1 by omega C minus omega L equals to R, omega square LC 1 minus omega RC. Here L known, R known, omega known. Is the only one equation we need to derive it from. We need to derive capacitance from this one. So we will get capacitance equation value as 328 microfarad. So after getting this one, we need to calculate the resonance circuit, that is series RLC circuit. The resonant frequency is 1 by 2 pi under root LC. If we substitute, we will get it as 35.9 Hertz. Hence option D is correct.